You have received the signal. Welcome to the last transmission. Wherever you are listening from and whatever the day has asked of you, I hope you can set it down for a little while. For the next few minutes, there is nowhere else you need to be. You are here among people who still look toward the darkness with curiosity, who believe unanswered questions are worth following, and who understand that sometimes the search itself can bring us a little closer together. Tonight, we will follow one of those questions toward a seemingly ordinary star, where an unexplained shadow caused humanity to wonder whether someone else might be looking back. Now settle in. The transmission begins. It was the headline that broke the internet. Have we found an alien megastructure? Most scientists remained deeply skeptical, but Tabby's star forced the world to seriously ask the question. This is the complete, grounded story of how humanity pointed its greatest telescopes at a single star and listened for life. The star's official name is Key C, 8,462,852, sitting about 1,470 light-years away in the constellation Cygnus. By all appearances, it's ordinary. An F-type main sequence star, about 50% bigger than our Sun, roughly 1,000 degrees hotter. Nothing about it should have made headlines. But something was blocking its light, and no one could explain what. The story begins with NASA's Kepler Space Telescope, which launched in 2009 with a clear mission: find planets around other stars using the exoplanet transit method. When a planet passes in front of its host star, the star dims slightly. Kepler watched over 100,000 stars, measuring their brightness with extraordinary precision. Automated algorithms crunched the data, flagging clean periodic dips that signaled orbiting worlds. The algorithms missed KIC 8,462,852. The human eye didn't. A citizen scientist named Darryl LaCourse was volunteering with Planet Hunters, a crowdsourced project on Zooniverse.org where ordinary people examined Kepler's light curves. LaCourse flagged the star because its behavior was unlike anything else in the dataset. Over Kepler's 4-year observation window, the star displayed 10 separate dimming events. Some dropped by less than 1%. Others plunged by as much as 22%. They were asymmetric, aperiodic, and genuinely bizarre. To put that in perspective, a Jupiter-sized planet crossing in front of a Sun-like star blocks roughly 1% of its light. Whatever was dimming Tabby's star had roughly 1,000 times the area of Earth, and it wasn't behaving like any known planet. In September 2015, astronomer Tabetha Boyajian and her collaborators posted a preprint describing the discovery. The paper's subtitle was disarmingly honest: "Where's the flux?" Colleagues quickly shortened that to the WTF Star, and the nickname stuck for good reason. As Boyajian herself said, "When I looked at it, I thought, that's clearly not anything that we know stars do." Then Jason Wright entered the conversation. An associate professor of astronomy and astrophysics at Penn State, Wright had spent years thinking about how we might detect advanced extraterrestrial civilizations, not through radio signals, but through their engineering. His reasoning traced back to physicist Freeman Dyson, who in 1960 published a paper in Science proposing that a sufficiently advanced civilization would eventually need to capture most of its star's energy. Dyson pointed out that planets intercept only about 1/1000th of their star's radiation, and the rest is simply wasted. An advanced species might surround its star with a swarm of orbiting collectors, a concept that became known as a Dyson sphere, or more accurately, a Dyson swarm. Wright looked at Tabby's star and saw something that fit the profile. Aliens should always be the very last hypothesis you consider, he told The Atlantic. But this looked like something you would expect an alien civilization to build. By October 2015, the story had gone viral. Every major outlet ran with the alien megastructure angle. The SETI Institute trained the Allen Telescope Array, 42 antennas nestled in the Cascade Mountains of Northern California on KIC 8,462,852. They scanned radio frequencies between 1 and 10 gigahertz and found nothing. No narrowband signals, no broadband emissions. Those observations ruled out omnidirectional transmitters operating at roughly 100 times Earth's total energy usage. Optical searches from the Boquete Observatory in Panama came up equally empty. The absence of signals didn't solve the mystery. It just deepened it. In May 2016, Boyajian did something unconventional. She launched a Kickstarter campaign to fund continuous monitoring of the star, with a goal of $100,000 for a year of telescope time on the Las Cumbres Observatory Global Telescope Network. 1,762 backers pledged over $107,000. More than 50 amateur astronomers joined through the American Association of Variable Star Observers, providing near-continuous coverage. It was citizen science funding citizen science. Then came the breakthrough. On May 19, 2017, the star dimmed again in real time. Boyajian stayed up all night watching the data, and at 5 in the morning, when it was clear the star was losing flux, she called Jason Wright. Telescopes around the world swung towards Cygnus. This time they captured multi-wavelength observations, and those observations changed everything. The star dimmed less in infrared light than in ultraviolet, and that single fact was devastating to the megastructure hypothesis. Any solid object, whether a planet, a space station, or a Dyson swarm component, blocks all wavelengths of light equally. Only dust does this. Only tiny particles selectively scatter shorter wavelengths more than longer ones. Juan Meng at the University of Arizona delivered the verdict plainly. This pretty much rules out the alien megastructure theory, as that could not explain the wavelength-dependent dimming. The researchers found the dust grains were similar to interstellar medium particles, tiny as campfire smoke, and newly created because the star's radiation would push grains that small out of the system quickly. Something was continuously generating fresh dust, orbiting with a period of roughly 700 days. In January 2018, a landmark paper confirmed dust as the primary explanation. As Boyajian noted, whatever is passing between us and the star is not opaque, as would be expected from a planet or alien megastructure. Jason Wright took the news in stride. "It means we get to have more fun," he said. "The fact that it turned out to be boring old dust is what everyone expected." Dust explained how the star was dimming. It could not tell us why this seemingly ordinary system was continually producing enormous clouds of microscopic debris. Something was happening around Tabby's star, something violent or unstable enough to keep replenishing dust that the star's own radiation should have swept away. Astronomers proposed colliding asteroid swarms, families of disintegrating comets, and even a disrupted exomoon, slowly losing its outer layers of ice and carbon-rich rock. Each explanation could reproduce part of the evidence. None could account for everything Kepler had seen. Then the system began revealing that it might not be as ordinary as it first appeared. In 2021, astronomers confirmed a red dwarf companion orbiting approximately 880 astronomical units away, nearly 30 times Neptune's distance from our Sun. That companion was far too distant to pass in front of Tabby's star from our perspective, but its gravity could have disturbed the system over immense stretches of time. Then, in July 2026, a study published in the monthly notices of the Royal Astronomical Society presented evidence for something much closer. Using TESS photometry and 20 new radial velocity observations, researchers identified a symmetric transit recorded in September 2019. The event was consistent with an object approximately 9.4 times the mass of Jupiter, orbiting Tabby's star at a distance of 2.35 astronomical units. The famous Kepler dips had been uneven and distorted, resembling clouds of dust with ragged edges. This event was different. Its light curve was smooth, round, and balanced, the signature expected when a solid, roughly spherical body crosses the face of a star. If that companion exists, it may be the missing force behind the entire mystery. Its gravity could scatter comets and planetesimals from distant orbits, sending them inward where they collide, fracture, evaporate, and continually produce the dust that first drew humanity's attention to this star. The evidence has reached only 2.3 sigma significance, below the threshold required to claim a discovery. When Wright saw the result, his public reaction consisted of a single, cautious word. That hesitation matters because Tabby's star has already taught us how easily wonder can race ahead of evidence. Yet this time, we may not have to wait for years to learn whether the object is real. The next predicted transit window opens in October 2026. If the object crosses the star again, telescopes on Earth and in space may be able to watch it happen. ESA's Gaia satellite completed its final observations before its decommissioning in 2025, and its fourth data release, expected in December 2026, may contain another piece of the answer. For the first time since this mystery began, humanity knows when to look, and somewhere in the constellation Cygnus, an unseen object may already be moving toward the narrow line connecting its star with our small world. Whatever we witness during the next transit will already be ancient, because every fragment of information reaching us from Tabby's star has spent approximately 1,470 years crossing the darkness between the stars. The light entering our telescopes today began its journey before humanity possessed a single instrument capable of receiving it, carrying the record of an event that occurred while the people of Earth were living beneath skies they could see but could not yet understand. Those photons continued toward us while generations were born, raised their children, searched for meaning, and disappeared into history. They crossed the emptiness while humanity endured wars and plagues, built cities and observatories, discovered electricity, learned that the stars were distant suns, and slowly acquired the ability to ask whether anything living might be looking back. After traveling for nearly 15 centuries, that ancient light finally reached a spacecraft called Kepler, where automated systems searched its patterns for the orderly shadows of distant planets. The algorithms passed over the strange, uneven dimming because it resembled nothing they had been designed to recognize. But a citizen scientist sitting at home looked at the same data and understood that something about this star deserved another look. That quiet act of attention eventually brought professional astronomers, amateur observers, radio telescopes, optical observatories, and thousands of ordinary people together around a point of light too faint for human eyes to see without assistance. When Tabby's star dimmed again, instruments across the planet turned toward Cygnus, and for a brief moment, people separated by borders, languages, and entire ways of life became members of the same watch, waiting beneath the same sky for an answer that had already been traveling toward them for centuries. Everything we have observed can still be explained without an alien civilization, because dust remains the strongest explanation for the strange shadows crossing the star. Yet the source of that dust remains uncertain, the possible giant companion remains unconfirmed, and the system continues to hold something back from us, as though the universe has revealed just enough to remind us how much remains beyond the reach of our understanding. There is another consequence of the distance that is almost impossible to comprehend, because if someone near Tabby's star were looking toward our sun at this very moment, they would see Earth as it existed nearly 15 centuries ago. They would see a world with no radio transmissions, no artificial satellites, no footprints on the moon, and no telescopes capable of searching the galaxy for signs of another mind. They could be staring directly at the place where humanity would eventually arise as a technological civilization, studying our sun with instruments more powerful than anything we can imagine, and still conclude that there was no one here. That may be one of the deepest forms of loneliness written into the structure of the universe, because two civilizations could look toward one another across the same darkness, each searching with everything it had built, and each seeing only the other's distant past from an age before either had learned how to announce its presence. Both could be listening, both could be hoping, and both could spend their entire existence believing that the silence meant they were alone. Perhaps there is no civilization near Tabby's star, and perhaps the strange shadows will eventually be explained by comets, collisions, gravity, and dust. Science asks us to remain patient enough to accept that possibility, even while something deeply human continues reaching beyond the evidence and wondering whether another living mind has ever looked toward our faint yellow sun. That question has followed our species for as long as human beings have stood beneath the stars. And it has survived every expansion of our knowledge because each discovery has made the universe larger, older, and more filled with places where another story might have begun. Somewhere beyond the constellations we named, oceans may move beneath unfamiliar moons, cities may shine beneath suns we have never seen, and living beings may be asking their own version of the question that has haunted humanity since the first person looked into the night and felt the unbearable size of everything beyond our world. We may never hear their voices, and they may never know that humanity existed, because the distances between us may prove greater than the lifetimes of civilizations. Yet every telescope we build, every signal we examine, and every strange point of light we choose to investigate becomes an expression of our refusal to let that distance end the search. Tabby's star has given us no message and no evidence that someone is waiting there, but its ancient light reached Earth and caused an entire species to raise its instruments toward the darkness. A citizen scientist noticed what the machines had overlooked. Thousands of people answered, and humanity listened together for a voice that might have begun its journey before any of us were born. The answer has not arrived, but the search itself has revealed something about who we are. Because on a small planet suspended in an ocean of darkness, a young species has learned to recognize the light of distant suns and wonder whether someone beneath one of them is feeling the same loneliness. Perhaps, long after every person alive today has disappeared, a signal from Earth will finally complete its journey across those 1,470 light years. Perhaps it will reach a distant receiver beneath an unfamiliar sky, where another living mind will notice something its machines dismissed, examine the signal again, and understand that somewhere across the darkness, separated from them by an ocean of time, they were never the only ones who looked toward the stars and hoped that someone else was listening.